And now comes the most interesting part, because now we're going to implement whatever we have learned, all of these steps over a practical real data set. So let us jump to the data set. So for example, if you have this fictitious data set carried out by a chain of hotels, and these hotels have branches in places like Delhi, Bangalore and Maharashtra. So the hotel management people are having a trend that they're actually able to spot out that some customers are regular, that is one, and some customers are not regular, so that is they are not visiting the hotel again. And let us assume that this data has been carried out, or all this information has been taken for a year. So within the span of 1 year, whatever customer database that the hotel people had or the hotel management people had, they are having a trend that some customers are staying with the hotel and regular customers, and some customers are not visiting the hotel again and again within a year. Now you as a data analyst are given this data set by the hotel management people, and you have to spot out the differences, what they should do now so that the customers are more regular. So basically the hotel people are worried that people are leaving the hotel, because if there is zero, it means the people are not regular, and if it is one, means the people are regular. So the hotel people are worried that what they should do so that the people are more regular visitors to the hotel. Now for now your task is that based on all this data, you will predict that if a new customer has arrived to the hotel, whether that customer will be regular customer or a not regular customer. So let us discuss the dataset features one by one. So these are just the number of rows, not number of rows actually, just the row ID, basically first to second row. Then we have the customer ID. This ID, suppose it can be any ID that is there in the customer or the hotel's database. Then this is the name of the customer or surname in particular. Then these are just some points they can be devised by the hotel people based on the customer's availability or whatever. Then these are the branches of hotel. So basically this customer visits the hotel branch in Delhi, this customer visits in Bangalore, this customer visits in Maharashtra. Then the gender of the customer, then we have the age of the customer. Years means from what year is the customer to the hotel. Suppose for example this customer Sharma is a customer to the hotel since 4 years. This customer is a customer to the hotel since the past 10 years, and so on. And then spent amount. So this is the amount that the customer has spent in the hotel for the products or whatever items that are available. Then these are the number of items. So there can be any number of items available in the menu. So this customer has bought suppose two items in their menu, and so on. Online payment means this customer can provide online payment. They can pay online. Zero means the customer cannot pay online. Online orders. So there are many apps like say Zomato or Swiggy. One means the customer is using online apps. Zero means the person is visiting the hotel or dining in the hotel. Then estimated salary of the customer, and then we have regular customer or not regular customer. Now for the coding part or the practical implementation part of the neural network, you can use whatever editor that you like or whatever type of file. So generally I tend to use .ipy, that is Python notebook files, or you can use .py files as well. That totally depends on you. So an editor as well, I'm going to use Google Colab because all the features are readily available, and you don't have to install the external libraries again and again. But if you are using anything else like Jupyter Notebook, then you'll have to install Tensorflow, etc. into your environment. But TensorFlow is readily installed in Google Colab. That depends on your choice. I have already uploaded our hotel data set that I showed you all before. Let us just open it and see what is there in it. Okay, that's our dataset. And in the table of contents, we have divided this artificial neural network into different phases. So the part one is data pre-processing, then we'll build the neural network, then we'll train the neural network, and we'll make predictions and evaluate the model. That is forward and backward propagation. So let us build our first artificial neural network. So let us close this and let us import the libraries. So whatever libraries that you're going to need, we are going to need NumPy and Pandas. And one more library that you're going to need is TensorFlow. So let us import TensorFlow, as classically known as TF. And remember, if you're using Google Colab, then TensorFlow is readily pre-installed in Google Colab, but you have to import it. And if you're using any other environments, like if you're using Anaconda, if you're using Jupyter Notebook, then you'll have to install it using pip install TensorFlow. And let us do one thing, let us run this code and let us check the version of TensorFlow. So I'll just write tf.version __ version. Okay, the current version of TensorFlow installed in Google Colab is 2.8.0. Okay, now let us import the dataset. So to import the dataset, I am just going to write df equals to, let us call it df like data frame. So df equals to pd, and if you have to read a dataset, the command is pd.read csv. And over here you provide the path to the dataset. So over here I have already uploaded my dataset, so I'm just going to copy the path, paste it over here, and let's just run this code. Okay, no error, it means dataset has been imported. Let us just check the header of the dataset. That means the first 5 rows. Okay, we have our dataset readily available. Now let us assign x and y values. Now to get the values of x and y, the value of y is going to be of course regular, and the x is going to be from rows up to the estimated salary. So actually we can exclude rows and customer ID because they won't be the deciding factor in predicting if the customer is regular or not. As well as the name, because that won't matter, right? So we can exclude these three columns. So 0, 1 and 2 should be excluded, and we'll start from point, that is from the third index up to the index of estimated salary. So let us write x equals to capital X, and it is going to be equal to df.ilog, so that integer location, and which rows we are going to select all the rows, that's why a simple colon, and selectively starting from the third row and ending up at this particular index. But instead of knowing this index, we just have to exclude regular, right? And the index of regular is -1. So at the end we can simply write -1 so that we can exclude regular. And we'll just copy this thing, paste it again for y is going to be simply df of ilog of all the rows of course, and which column? Only the last column, so we'll only include this column. So let us print out the values x and y. Okay, and we want x to be from points, that is this thing, to estimated salary, and that's what we have gotten. And let us print out the value of y. Okay, y is also the last column, but for this to be the input of the neural network, that is going to be wrong, right? Because they expect the values, so we'll just write dot values for x and y. And now let us run this code. Okay, now we got these values and we can use it as perfect input for our neural networks training. Now if you see the values of x, we are having these two as categorical columns and no one else is categorical column, if I'm not wrong. So everyone is numerical value instead of this branch and gender column. So we need to change that to numerical values. So first of all, let us try to encode them by using a label encoder for the gender class. So over here, let us just simply put a line of code. And first of all, from scikit-learn.preprocessing, we'll import the label encoder and create the label encoder object. Now we want to change only some features, right? We just want to change the gender column. So that is going to be x of, and now see, we are going to take all the rows, and from the columns, we are going to take only the second column. That's why just 2 here. And just let us do one thing, let us just copy this, and this is going to be equal to le, because this is the object of label encoder class, dot, we are going to use the fit transform method, and the input is going to be x of 2. That's why I copied that, and let us just run this code. Okay, it has executed. Let's print the value of x and see what happened. Yeah, the values of males and females has been encoded to 1 and 0. After that, we want to encode the branch column, which is the categorical column. So for that, we are going to use one-hot encoding. So syntax is pretty much easy. From sklearn.compose, we are going to import column transform and one-hot encoder. And column transform is going to be a column transformer object, and the transform is going to be an encoder because we want to encode the values. And for that, we are going to use the one-hot encoder method that we imported right now. And which is the index? The index is going to be 1, because if you see over here, the index of this particular column is 1, because 0 and 1. So the first column, that is not first column, that will be the second column, but the index is 1. We're going to use the remainder as pass through, and we're just going to use column transform dot fit transform of x, and let us just run this code. And to check if it is working or not, let us do one thing. Let us just shift this cell down and print the value of x. So okay, we got perfect values for x, which are all numerical values. You might have not understood what exactly happened here. So let us see exactly what happened. So first of all, the value of x was Delhi, Bangalore, and this one is Maharashtra. So you can see that what this one-hot encoder did is, for Delhi it encoded the value was 010. For afterwards, I think there was Bangalore. For Bangalore, the value is 100, and for Maharashtra, the value is 001. That's how we encoded the values. Now, after every value of x is numerical, every feature of x is numerical, we'll just simply split our training set into train, test, and split parts. We'll use a test side of 0.2, that is 80% of the test set will be training and 20% will be the testing set. Now, the next step is feature scaling. Remember that feature scaling is compulsory before sending in the data into the neural network. So whenever you build an ANN, it is very important that you scale the data. The values of x can be anything. So even if the values are zeros, ones, it is not that you should not scale them. You should scale each and every value of x before sending it into the neural network. So for that, we are going to use scikit-learn preprocessing model known as standard scaler, and SA is going to be the object. Now we are going to fit transform the values of x train, and for x test we are going to just transform the values. Why? Because we don't want information leakage. Now let us print out the values of x train and x test. So as you see, we've gotten scaled values for xtrain and xtest.